It's great to be back at HITS. I had a great time here, and I have very fond memories of climbing up to HITS, leaving the city, which is a quiet city, but up here it's even quieter, and it's a lovely place for thinking and for coding. In 2012, Volker Stollertz, a well-known and award-winning science journalist, came also to HITS as the first journalist in residence. And he wanted to learn more about how data-driven science works. So Volker visited the different research groups at HITS, including the SDVV group. And it was during one of these visits that the idea was born for a data journalism application, the Operation Explorer. But more on that later. More importantly, during his visit to HITS, Volker also met Klaus Tschira and was able to convince him of the need for a German Science Media Center. And 3 years later, 2015, the Science Media Center Germany was founded. What is the Science Media Center? It's a non-profit and editorial independent organization. It's an intermediary between journalism and science and helps scientists to report on public issues. Public issues are important topics for the public interest that have a relation to science. The Science Media Center has different offerings for journalists, and we provide them for free. And they are not products, they are not journalistic products, they are quite more like raw material, which journalists can use to make their products, their articles, their radio reports, for example. And over the last 8 years, the SMC has grown quite considerable. And our editorial team covers now a broad range of topics from climate science, environmental aspects, AI, digitalization, life science, and medicine. And we are in contact with many scientists and journalists. And we are every day broadening our network in those both directions as an intermediary between those groups. The main funding of the Science Media Center is provided by the Klaus Tschira Foundation, but we have also a broad network of sponsors from different areas of science, business, and media. And how does the SMC work? How do we make, or how do we try to make an effect on the media system? And I think that's a good example. It's maybe a bit old, but I think it's still enlightening. It's from 2020, and in 2020, DeepMind announced that it has solved the so-called protein folding problem. And at this time, this was quite a niche question in a niche research area. But we immediately saw the potential and the impact, or potential impact, of this proclamation. And we then asked in our network of scientists we have in our databases for assessments. We asked scientists to assess the claims of DeepMind, and they provided us with we asked nine scientists, and they provided statements that we then distributed to science journalists. And those science journalists could then use those statements to enrich their writing about this event. But this question was so esoteric in some kind of sense that at this time, most journalists hadn't seen this issue if we had not made those statements. And so we helped them to make some reporting on this quite important finding by DeepMind. And so we sent out 9 expert statements, and those were used by 25 citing media organizations in 71 single citations. And so this topic was reported on in Germany, Austria, and Switzerland. And one journalist said that she was very grateful because she would have otherwise missed this topic. if we hadn't made this offering. And this is a way how we work as an editorial team. We highlight topics, we enrich reporting on topics by giving scientific expertise into the discussion. When the SMC was founded, it was certain that we would like to have, in addition to the editorial office, a lab for research and development in the area of technological support for science journalism. And so we founded along the editorial team the so-called SMC Lab. And the SMC Lab is responsible for IT services, for data science and research and development at the SMC. At the moment, we are 9 software developers and data scientists, and we support the SMC's mission as public interest technologists. And we gave ourselves those purpose motto of augmenting science journalism, augmenting as meaning supporting and improving science journalism by using technology, whereby we don't want to automate or replace journalism as a human profession. We want to support it. So augmenting science journalism. And in this talk, I will show you 3 different areas or ways we tried to reach this goal of augmenting science journalism. One is through research tools like the Operation Explorer, with related workshops where we make an offer to journalists to learn how to use those tools, by providing tools for monitoring and making it easier to find new scientific experts, and by supporting the adaptation of science journalism to ever-changing journalistic ecosystems. As I have already mentioned, the development of the Operation Explorer began when Volker Stollertz was a journalist in residence at HITZ. And at this time, Volker and other science journalists were very interested in uncovering the regional or temporal patterns in healthcare provision in Germany. Are certain diagnoses made more frequently or certain procedures performed more often in different areas of Germany? The approach at that time was to manually process and check the data in Excel as a spreadsheet in response to a suspicion they already had. And the Operation Explorer automated this manual work and enabled the hypothesis-free exploration of data. At the SMC, the Operation Explorer was used in investigative research that was prepared centrally at the SMC and carried out and distributed decentrally with regional journalists. One impressive example was in the research that had shown that there was an accumulation of spinal operations in the area of Fulda, where some doctors made some kind of spinal operations for every spinal cord separately, so to get more money. This was uncovered by exploring the data, and then regional journalists in the Fulda area really get into the deeper research and uncovered the structures behind those data points. And this research led to a documentary which was shown in the public television. There you can see Wolfgang Müller and me drawing up plans in the HITZ cafeteria, and was also picked up in local regional newspapers. And this combination of research tool and workshops was also the approach we took for a series of offerings that we called model-driven fact sheets. The idea came from Brett Victor, who was already very early thinking about how to improve the media discussion on political measures in the area of climate protection. And his description of the problem was that complex issues are simplified in media discussions without the assumptions and the range of possible other interpretations being made explicit. So how could complexity be discussed as complexity without being overwhelming? And his idea was to use models for the explanation of complex issues, but also models can also be very complex and different to understand. So he devised several scenarios he wanted to show as guardrails, limiting the models for exploration, but thereby not restricting the possible path of the models to those guardrails, but use them as a starting point. And we took this idea and adapted this to a series of model-driven fact sheets on the topic of energy transition, Energiewende in German. And in these tools, we tried to highlight the various development paths in scenarios and to inform political discussions with it. For example, what happens if you make the coal transition faster than planned, if you are not able to build new power stations using gas quickly enough, and all the questions we could show in a data model and make the calculations, and had workshops together with the journalists and scientists working in this domain, where we could discuss the questions of the journalists and also provide some tooling for the journalist to play around with the data, to maybe answer their own questions or to generate new questions. And in this sense, there's also data-driven editorial offering at the Science Media Center that we call data reports. This format has its origins, of course, in the daily reporting on the data regarding the corona pandemic. But this format has also proven worth in other topics, such as the gas crisis and for individual analysis. And so we offer this data report with interpretations, but we also offer code snippets and prepared, cleaned data that could be used by data journalists for their own work. And two examples you see on the right, where this data reports had an effect we could measure, was that on the one hand, you have a nice infographic built by Quarks for social media, where they took over some data we had provided in a data report. But more important, I think, is the other case where the NDR, Northern Germany Public Radio, took over our way of thinking about the gas storage crisis in ways of scenarios. So they introduced the way of thinking in scenarios into journalism, and thereby a broader public was the first time maybe they see, oh, there are possible development paths in this area. They're not just random data points shouted by someone in the debate, but there's a range of possibilities, and we can track where we are and where we are going. Second way of augmenting science journalism was by providing tooling for monitoring, scanning, and scouting. Then, because one reason why science journalism is so challenging is it's really hard to maintain an overview in all the information that's out there and to quickly recognize what's really important. So you have to really have good filtering mechanisms, a good network of experts that can help you to get to the real important issues. And experts can help with that, but then you have to find the real scientific expert that can help. And that is a problem in itself. So to address those problems, we have developed two prototype applications. A preprint recommender that helps to filter preprints on bioRxiv and medRxiv. These are two preprint servers that have also been used by science journalists in the pandemic a lot. And the so-called Expert Explorer that supports the search for experts in the publication data on OpenAlex, which is a free source of scientific information. And our preprint recommender works by collecting metrics that are freely available from bioRxiv and medRxiv. And those metrics are number of abstract views, number of PDF downloads, and the altmetric score, which measures some kind of social media interaction, and but also if something is mentioned on a collection of media outlets. Then on this data, every 2 months, there are confidence bands that are calculated for each of these metrics. And then we take those new publications that are above the 99th band within this period, so the first 7 days, and then highlight them and give an email alert to the editors to have a closer look at these preprints. And those preprints can get an alert for different reasons, because there are different metrics and they have different reasons to get above the 99th band. For example, you have the one recent preprint was how smart was a T-Rex. So that's interesting because it's about dinosaurs, and it's always interesting to learn something new about dinosaurs. And there you see that you have a early peak in the altmetric score, so high social media interaction, but the PDF downloads never went up beyond the limit for the first 7 days. And the other study is something collecting information about a technique in bioinformatics or biology. And there you have another pattern where there's a deep interest by scientists in high PDF downloads. And later on, there's also some social media buzz. And so our editors get the first signal that might be something interesting, and then they have to do a deeper look and can use our dashboard to do this with live information about those preprints. The Expert Explorer, as I said, is using OpenAlex as a quite new, open and comprehensive database of scholarly data, so papers, authors, institutions. And it's a good source, a good starting point for search applications that wants to find experts based on their publications in the field. What OpenAlex does is that it's automatically assigns concepts from its own taxonomy to publications. These concepts related to publications are then inherited from the publications to authors. And we want to search for authors based on a concept and use then bibliometric indicators to assess who might be a relevant expert for a query. But the first problem is, which concept is the right one to choose if I'm not an expert in the domain I'm searching experts for? And we are testing 3 ways to support the user in choosing those concepts. First one is that we enable the input of a known scientist. Maybe I know someone in the field who is a good scientist, someone I consider an expert. And I can then make a search in OpenAlex using this experts, the scientists, and look for the concepts that are tagged to this person. And this is quite interesting because it helps really with navigate in the landscape of concepts used by OpenAlex. Then, for example, if you search for experts for the Ebola virus, you would naively enter Ebola virus as a concept, but most scientists working in the field are tagged with the more specific Zaire Ebola virus. And by getting the concept of a well-known expert, you get some help with finding out those details of the taxonomy. Then you can, of course, map some free text you input to Wikidata. So we use a Wikidata endpoint, and there you have a search on concept labels, descriptions in several languages, and then try to find a good mapping to your search query. And with the advent of large language models in the last 1.5 years, we also tried to use them to have a tool where you can just enter your search intent or an abstract or something you want to to enter to specify what is the domain I would like to search experts for, and then use a large language model to extract candidates for concepts, which are then mapped against the taxonomy of OpenAlex. And all this helps a lot with the first entry barrier for searching experts using concepts. And then you can select several concepts and make a search in OpenAlex. And then we aggregate some bibliometric indicators. Some indicators come along with the data of OpenAlex. And there are others that had been shown really important, like the number of citations, publications of the authors retrieved that are tagged with this explicit concept you have searched for. Because otherwise you would get many hits for experts that only on occasion worked for a topic, or where the OpenAlex tagger, concept tagger, used a broader concept to tag experts. So this metric number of citations of publications with the papers searched for, it's really important, and can also make a deep dive into the publications of the experts you have found to really be sure that it's a good potential experts for your use case, and then try to contact them. Our tests so far have produced a mixed picture. The process works well for some domains, especially life sciences and medicine, but hardly at all for others, especially engineering is a hard topic. And we are currently validating the Expert Explorer against our own database of experts we have built in the Science Media Center, and are trying to systematically determine which problems there are that lead to poorer search results. The third area or way of augmenting science journalism is that we help science journalism with adapting to ever-changing ecosystems of journalism. So the conditions under which journalism is produced are changing rapidly, and not only the economic, but also the technological landscape is changing right now. David Caswell, an important thought leader in digital journalism, sees the field in the midst of a double disruption, as everyone can now do everything everywhere all at once. We have the first disruption, this is a bit older, but it's still important for journalism, is that the advent of social media has democratized the distribution of content. The world of broadcasting has changed into a world of many-to-many communications. Journalistic offerings compete with an ever-growing alternate supply of information, but the attention of the recipients is always constant, limited, and not enough. And then the second disruption is that generative AI has democratized the content creation. That means that now teams, that one-person teams, individuals who are able to use new tools coming out are competing with teams of specialists, like in the old media outlets. And what can science journalism do to respond to these challenges? And that is something we also work on, thinking about these issues, testing solutions. And one of the proposed solutions for the for the problem that the journalism is now in a many-to-many communication world is that we maybe have to think journalistic products in a different way. We have to start by building modules as semantic unit of news that are pre-produced and then are reassembled in a certain way for different user groups and user needs. So in this way, journalism could be able to with limited resources, offer many different presentations to different user groups. And that is something we now try in the SMC with our own offerings. So we are applying the paradigm of modular journalism to our own content. At the moment, our content is an archive, a text-based archive of our offerings, like the statements I've shown in the beginning. And there's no structures and not structured data, unstructured text data, which is not reusable. And we now try to break them up into modules, into a data structure, makes them reusable, recombinable, and then enrich them with metadata to make them more usable. And this new database of modularized content will drive our new website in the future. And these modules will also be delivered by an API. And maybe they provide the suitable content as a part of retrieval augmented generation approach. This is a way where you can use custom data, your own data in the context windows of large language models to produce the output. And I think it's a good idea to have very precise modules with good content, with a good description of what to use in which context to retrieve the right results for the context window, and then use large language models to generate outputs out from these modules. And there's a lot of excitement in the field of journalism regarding generative AI, but it's not yet, there's yet not much clarity about what that will do with journalism. So we're keeping a close eye on the field and passing on our knowledge to science journalists. We have a blog where we describe how you can use paradigms like retrieval augmented generation to enrich your content or give your content to large language models to produce different outputs. And we also had our first SMC Lab hackathon last year, where we worked together with science journalists to produce some kind of prototype using those approaches to generative AI. And another thing that interests me personally is the question of what entirely new possibilities generative AI could enable for journalism. And that beyond the Turing trap, that is with which Eric Brynjolfsson described the clinging to the imitation of human abilities by artificial intelligence systems. And if you try to get out of this Turing trap, you can ask which entirely new formats could become possible in education and science communication if we can free ourselves from the limits of scaling. But what would be the equivalent in journalism? So there I'm really curious. In any case, the latest wave of new machine learning methods has led to completely new approaches in journalism. Who would have thought that object recognition algorithms would one day be used to spot elephants from space? And that this tool would open up a whole new approach to investigative journalism, like in the right example, where there was illegal cattle tracked from space using satellite imagery. And maybe someone who has been able to think beyond the limits might answer the question. And in this spirit, thank you for your attention, and I'm happy to answer your questions.